Next kind of integration is when you need to integrate something in the form of a square root 1 minus x square as well as square root a plus x square. Actually, these two are given in your formula sheet, okay? But before that, like I say, you need to know, differentiate sine inverse, I get 1 over square root x square. But the formula is only given you in general form. So if you need to differentiate like sine inverse x square, what are you going to get? Still, you can apply this into your formula, okay? 1 minus, when this is x square. So the angle is just here as a square. When we differentiate, we always need to multiply by the differentiator of the angle. So what's missing is, you need to multiply by a 2x over here. So that is where you get 2x over square root 1 minus x to the power of 4. Same thing for cosine inverse and tangent inverse. Okay, so when you differentiate tangent inverse, sine inverse, remember you can apply, this is given in your formula sheet. You must know how to change the angle as well as multiply by the differentiator of the angle. Okay, and even in integration, you are actually given these 4. Okay, you are given these 4. Like I said, these 4 are always in general term. This x here is the angle that is here. So it can be in a certain form, the angles can change, something like this. So if you can make it to become integral of 1 over x minus 1 square plus 4. This is the same as the integral of 1 over x minus 1 square plus 2 square. Then you can immediately apply, or once I get the same form of this, I can apply this. The a is 2, inverse tangent, x minus 1 over 2, because the angle is x minus 1. So I replace the x with x minus 1. And it will just be this way. So know how to use your formula to help you. Okay, but this can only work if you can put it in terms of x square. If it's x power 4, x power 6, you can't. Then you have to think of it as the reverse. Okay, what do I mean by that? There are 4 examples that is over here. So for A and B, okay, it's quite straightforward in the sense that A is just take out the 7, 1 over square root 1 minus x square. You have to be able to see, integral of square root 1 minus x square. I differentiate what I get 1 over 1 minus x square. That would be inverse sine. And what is the angle? The angle is just x plus c. Okay, for the case of B, where this is not 1, because given in your formula sheet, there's a differentiation and an integration one. The differentiate d dx, I'm just going to write here. Differentiate inverse tangent x is 1 over 1 plus x square. Your x square, okay, need to be this form. Or you can actually apply this into your formula sheet by doing this. 8, 1 over, this is 2 square plus x square dx. Then you can look at your integration one. Which one do I apply to? The first one, because it's x square plus a square. This is going to be 1 over 2 inverse tangent x over 2. There's an 8 on the outside, so multiply by 8 plus c. Make it nice. That's the answer. 4 inverse tangent, okay, x over 2 plus c. Now, like I say, the formula sheet can only help you if it's in terms of x square or bracket of x square. What if it's not? What if it is like c, where it is the integral of the 5 take out, x square over square root 1 minus x to the power of 6 dx. Now you have to identify, what is my angle? Okay, let's ignore the x square on top first. My angle is 1 minus x to the power of 3 bracket square dx. Now the first thing that comes to your mind is, I differentiate what I can get this. I know that in order to get over square root of 1 minus something square, I must be talking about sine inverse. So you must write down here, sine inverse. The angle is x cubed. Okay, what am I going to get? 1 over square root 1 minus x cubed to the power of 2. Remember to differentiate the angle. That's where the 3x square comes in. So you know that I need to get 3x square as my numerator, 1 minus x to the power of 6. Is it 3x square over here right now? No. So how do I get, if I want to have a 3 as a numerator, I must compensate with a over 3 on the outside. 1 minus x to the power of 6, right? Yeah. Then you look at here. This is Mr. B. Integrate Mr. B. I get back who? I'm just going to get 5 over 3 inverse sine. My angle is x to the power of 3 plus c. Understand integration as a reverse of differentiation. Then it will be so much easier to do. Okay. The next one. Integral of 6x over 4 plus 9x to the power of 4 dx. Same thing. Is it x squared at the bottom? No. So let's try to take out the 6 first. X over, so if this is 4, it's a little bit harder to do. Make sure it is 1 first. But if you want to make sure it is 1, you need to take out a 4 here. 1 plus 9 over 4 x to the power of 4. This way. Take out the 6 over 4, that will be 3 over 2 on the outside. Integral of x over 1 plus. Now, if I want to put this in the bracket, what am I going to get? 3 over 2x square dx. Anything that is a 1 plus x something square at the bottom, think of inverse tangent. So, I'm going to write on my right side here, differentiate inverse tangent. What is my angle? 3 over 2x square. What am I going to get? 1 over 1 plus 3 over 2x square. Need to multiply by the differentiator of the angle. Differentiate this, I'm going to get 3x. That is why I have a 3x on top over 1 plus 9 over 4x square. There's a square here, power 4. So in this case, remember, this is Mr. B. I need to have a 3 on top, means I need to divide by 3 on the outside. I will get half integral 3x over 1 plus 9 over 4 x square. What am I going to get? Look at your working on the right side. I'm just going to get half inverse tangent 3 over 2 x square plus c. Okay, so there are many tools in integration that you can use. Later on, there will be more tools that's going to be introduced to you. You have your formula sheet. Do you know how to use your formula sheet? Do you know your differentiation good enough to use it as a reverse, integration as a reverse of differentiation? Okay, these are the things that you have to know first, be good at, okay, before we proceed.